All right, so just a recap. Here is our quadratic equation in vertex form. And we had three different translations. We had either A, which was a vertical stretch or compression. We had H, which was a horizontal translation, so moving left or right. And remember, you take the opposite sign that's inside the bracket. And then we had K, which was our vertical translations, up or down. So using this information, we are going to practice sketching quadratic equations that are in vertex form. So the first one, here we have 3. Okay, so let me just make a note of this. So A equals 3. Okay. Here H, well, it says -2. Remember, take the opposite sign. So we're going to have H as 2, and then K is 1. Okay, so HK actually tells us what the vertex is. So in this case, the vertex HK is already written for you. It's 2 and 1 right here, 2 and 1. Now we need to look at the direction of opening. So does it open up or does it open down? Okay, to do that, we're going to look at the sign of A. If it's positive, it opens up. And in this case, it is. So we're going to write opens up. Okay. Now, before I move forward, I want to introduce something called the step pattern. So I'm just going to do a little graph here. And I'm going to graph the function just x squared, your simplest quadratic. Okay, the vertex for that is at 0, 0, and it just goes up like this. Okay, so for this quadratic, we have steps. So here's the point 0. Right over here would be the point 1, and then 2, and then 3, and this is going to keep going. Okay, at the point 1, you're going to have the y value is 1, or the function will be 1. At the point 2, it goes a lot higher. It's going to be at the coordinate 4, and at the point 3, which is much higher, it's going to be at the point 9. Okay, so moving over on the x-axis, we just take simple steps, one each time. One step, one step, one step, right? 1, 2, 3. But moving up on the y-axis, we go 1, 4, 9. So in this case, we go up one step to 1, and then up 3 more units, so 4, and then from 4 to 9, we go up another 5 units. So notice that our step pattern for simply x squared, for our y coordinates, first we go up 1, and then we go up an additional 3, and then we go up an additional 5. Now in this equation, the value for A is 3. So it's going to be stretched quite a lot. And to actually sketch that, what we're going to do is we're going to look at our step pattern, but we're going to multiply those steps by the value of A, which in this case is 3. So you can imagine it as if you're using the distributive property and multiplying that into each step. So we're going to move up the first step by 3 times 1, which is 3. The second step, 3 times 3, which is 9. And the third step, 3 times 5, which is 15. So what we do first is we find that vertex 2, 1. So we go over here, we go on the x-axis to 2, and the y-axis on 1. There's the point 2, 1. Okay, let me zoom in a bit more. Okay, so here's the point 2, 1. Now our step pattern is what we're going to use now. When we move over on the x, and the x is always going to be 1, okay, so if we move over 1 on the x, instead of going up by 1, we're going to go up by 3. So we'd move over 1 and up 3. 1, 2, 3. Like that. So that coordinate, if our vertex was the coordinate 2, 1, this next point is going to be 3, 4. Right? Our x increases by 1, our y increases by 3. Then your x will increase by 1 again, and your y will increase by 9. So this isn't the greatest grid. It's sort of fading a bit. But sort of estimate you go over by 1, and then you go up by 9. All the way up. So you can count, if you like, somewhere up there, which would be the point 4 and 13. Okay. And then if we had room, we would go up another 15 for the next step. But we don't have room. So this is one side of the quadratic. The other side is going to be a perfect reflection. It's like symmetry. And so if it helps, you can just sort of take this point and move it to 1 over, right, to the point 1, 4. Okay, so instead of adding 1 to x, we're going to subtract 1 because we're going to the other side. But then we're still going to go up 3 steps. And then over 1 again to 0, and all the way up to 13. Right, this gives us a couple points to be able to have our sketch. So now we can sort of sketch the quadratic. You can see it's been very stretched. A factor of 3 is a fairly big stretch. Right, we have it opening up. We have it starting at the vertex, and our step pattern allows us to come up with some points to show how much we've actually stretched it. Now in this case, we start above the x-axis, and we open up. So it never actually crosses the x-axis, so we don't have any intercepts there. And let me just pause the video, see how everyone's doing. So in this next example, our a value is going to be -2 now. Because it's negative, that's going to tell us that it opens down. Opens down. Now for our step pattern, right, we don't need to multiply it by -2, just by a factor of 2. The negative just tells us that it opens down. So we're going to do 2 times our step pattern, 1, 3, and 5, which will give you our steps for this quadratic, which is 2, 6, and 10. Again, whenever I ask you to sketch something, most of the time, the last one is hard to sketch because it doesn't fit on your graph. But as long as you have at least 2 points there, then you'll be able to show more clearly how much it's either stretched or compressed by. All right, so first we need to start at the vertex. So where's the vertex? Vertex is h and k. Okay, vertex is a coordinate hk. And in this case, h is +3. Remember, again, opposite sign. And k is also +3. So we're going to start this graph at the coordinate 3, 3, right there. And you have to remember that we're going to be opening down like this. So when we do our step pattern, we're going to go, for example, over right 1, and then down 2. So 1, 2. So here's our next point. And then we're going to go over 1 again and down 6. So 1, 2, 3, 4, 5, 6, right there. And then you can go over 1 again and down 10 all the way down there. Then you just do the exact same thing on the other side. Right? Instead of going over 1 to the right, we're going to go over 1 to the left and down 2. 1, 2. And you should be able to see the symmetry here. These points should match up on the same y coordinate. And then over again 1 and down 6 all the way down here. So that's enough to see basically what it looks like. So then we sort of sketch that like this. And you can see we have 2 x-intercepts. All right, so let me just recap what we're doing. So if we know, take one function, the simplest quadratic function, x squared. What we technically want to do is take a bunch of points on x squared and then see where those points end up if we apply these three transformations. So what we do is we just start by taking some points. Okay? For example, the easiest points would be on our x-axis 1, 2, and 3. Okay, instead of choosing like 1.5 and 2.7 and 8.9, 1, 2, and 3. Okay. On our y-axis, you simply look at the equation x squared. So for our first point, our x is 1, and so our y is 1 squared. So our coordinate would be 1 and 1. When we go to an x coordinate of 2, our y coordinate would be 2 squared, so 2 and 4. And then when we go over on the x-axis again to 3, our y coordinate would be 3 squared, which is 9. So those are some great points, and they'll be the exact opposite on the other side. You sort of have a reflection about this axis, about this vertical axis, right? Your quadratic should look the same on one side as the other. Right? So if you went over to the left, you would still go up 1. Right? If you went over to the left again, you would still go up to this point 4. Right? So you would have minus 2 and 4, and all the way up here, minus 3 and 9. So what we want to do is figure out, okay, well, if I were to do the graph 2x squared, so let's say we did 2x squared, well, then our points wouldn't be 1 and 1, right? Because it would be 1 squared times 2. So instead of jumping up by 1, we would jump up 2 spaces. Right? So originally our jumps are 1, 3, and 5. So 1, 3, and 5 are for x squared. But for 2x squared, we first jump up 2 spaces. And then our next point wouldn't be 2 and 4. Right? This 4, which is 2 squared, would then be multiplied by 2. So it would actually become 2 and 8. So now what we're doing is we're jumping up from 2 all the way to 8, which is a jump of 6 vertical spaces. So you can kind of see where this is ending up. Right? Our original step going up on the y-axis being 1, 3, and then 5, right? 1, and then another 3, and then another 5, is becoming 2, 6, and you can probably predict what the next one is, because it's simply these ones multiplied by 2. So 5 would be a jump of 10. And so that's what we're doing down here. We're taking our step pattern for x squared, and we're saying, okay, we're going to stretch it by a factor of 3, but we're also going to start at this vertex, not 0, 0. So we're going to start here, and for every time we move one space in x, we're going to go up by 3. And then the next time we move another space in x, we're going to go up by 9. And the next time we move one space, we're going to go up by 15. And it doesn't matter whether or not you move one space to the right or one space to the left, because again, it should give you the same results there, right? You should have symmetry based on what it looks like on the left and what it looks like on the right. All right, so this example, you might be saying, where's the h? Like, what do I do? But what we can do is we can rewrite it as a half, and x squared is just the same as x plus 0 squared. It's no difference. And if you were to take away that 0, you just get x squared. But I mean, adding 0 doesn't do anything. And then we have plus 9. So that means our vertex is at 0 and 9. So that's where we're going to start. So let's draw that first. So 0 and 9 is all the way up there. There's 0 and 9. Now because a is positive, this is going to open up. So opens up. So it's going to go upwards like this. Okay, but the question becomes, how steep do we want to go up? Do you want to go like quickly or more wide, right? Is it being stretched a lot or is it being compressed? Now, since the value is between 0 and 1, it's going to be compressed. And what we're going to do is we're going to take this value and multiply our step pattern with it, 1, 3, and 5. So the first number we get is half. Second number we get is 1.5, or 3 halves. And the second number we get, the third number we get is 2.5, or 5 halves. So how are we going to draw this? So we're starting here. We're first going to move over to the right. Why? I don't know. I like moving to the right. And if we move over to the right one space, then we're going to go up just a half. Okay, so if you go over 1, we're going to go up a half. And I'm sort of estimating here because I can't really see the grid. And then, if I go over 1 again, I move up by 1.5 spaces. So 1.5 right there. And then if I go over by 1 again, I move up by 2.5 spaces. So 1, 2.5 right there. And then we can do the same thing on the other side because we're going to have this symmetry involved here. So instead of moving, let's go back to the vertex, and instead of moving to the right, we're going to go to the left and up by half. Then to the left 1 more and up by 1.5. Then to the left 1 more. We only ever move by 1 on the x-axis. Then we're going to go up 2.5. So those are our 5, well, more than 5 points, 6 points, no, 7 points. And we're just going to sketch it. Okay, and we can see from this we don't have any x-intercepts.